Hi, this is week 21 of chemistry, and in this week we'll be looking at unit 4, which deals with atmosphere. Now, for this week's agenda, we're going to go ahead and take a look at kinetic energy and how it affects gases and its properties. We'll also be looking at measuring pressure, plus how do you change from one unit of pressure to another. So let's go ahead and get started. Let's go ahead and get started with kinetic theory. In kinetic theory, it describes the behavior of gases in terms of particles in motion. There are three parts of kinetic theory. Number one, all matter is made up of small particles. Either it might be an atom, a molecule, an ion, ionic particles, but everything's made up of small particles. Part two of kinetic theory states that particles are in constant motion. Whether they are solid, a liquid, or a gas, these particles are in constant motion. And part three states that all of these collisions are perfectly elastic. What does that mean exactly? It means that when two particles collide against each other, they bounce off of each other without losing any of their energy. All right, so that is the theory we're going to go ahead and go with. In reality, a fraction of that energy is lost to either thermal energy, so that means some of the energy gets converted into heat, or it might be lost as sound. But we're going to go ahead and pretend that the collisions are perfectly elastic, so therefore we don't have to do additional calculations for that loss to kinetic temperature or also to sound. We're going to go ahead and study the properties of gases using our PhET simulation. And for our PhET simulation, we're going to go ahead and use it to answer the following 5 questions. This, how does a gas create pressure? How does temperature affect gases? How does temperature affect pressure? How does the number of gas molecules affect the pressure? And how does the volume affect the pressure as well? So again, we're going to go ahead and take a look at all of these in the PhET simulation and go ahead and come up with the answers for these questions. This is our PhET simulation dealing with gases. And our first question is, how does a gas create pressure? So what we're looking at here is we have a container that is completely empty. So therefore, it's got no pressure in it. So the first thing we're going to go ahead and do is go ahead and add some air to it. So we're going to go ahead and use the gas pump. And we went ahead and put some gas in there. And now you can see the pressure's gone from 0 to 17.3. It's going to fluctuate slightly. But how is it that the gas is creating pressure? That's our first question. How we're going to go ahead and answer that? If you look at the gas, it is the collision of each of these gas molecules against the walls of its container. That's what creates pressure. So each one of those collisions has a lot of force. So therefore, that collision against the walls of its container creates pressure. So that's our first answer. Our next question is, how does the temperature affect the gas? All right, so what we're going to go ahead and do is change the temperature. And right here at the bottom, we're going to go ahead and increase the heat. And now we're going to go ahead and take a look at what does that do to the gases when we heat them up. And if you look at these molecules, you're going to see that their velocity is changing. They're traveling at a faster speed. And that's a property of a gas. The more you heat up a gas, the faster the molecules travel. All right. Now, what happens if we were to cool this gas down? Well, the opposite will take place. So now we're going to go ahead and add some ice. So we're going to begin to lower the temperature of this container. And as a result, you'll see the average speed of these molecules to go ahead and begin to slow down. And now they're going slower and slower. All right, so our second question again was, how does the temperature affect the gases? And the answer to that is it affects their velocity. So if you heat up the gas, those gas molecules will travel faster. And if you cool down the gas, those gas molecules will travel slower. Our third question is, how does the temperature affect pressure? All right, so what is the relationship between temperature and pressure? So let's take a look at the pressure gauge on the top right corner. It's somewhere around 9. So how does the temperature going to affect the pressure? All right, so we're going to go ahead and again begin to heat up the container. And if you look at the pressure gauge, the pressure is increasing. So now you can make the connection. The more I heat up this gas, the higher the pressure. Okay, so I'm going to go ahead and stop heating there. Why is that? Well, here's the answer. because the molecules are moving faster, they're colliding more often against the walls of its container, plus they're colliding with more kinetic energy. So more kinetic energy, therefore more force, and that creates more pressure. So as we increase the pressure, as we increase the temperature inside of the container, the pressure will increase. Now, what happens if we cool down the gas? Well, those gas molecules are going to go ahead and slow down. So therefore, there's less collisions. And these collisions, not only are there less of them, but they're colliding with less force. So therefore, that decreases the pressure. So that is the relationship between temperature and pressure. Higher temperatures means more pressure. Lower temperatures means less pressure. Let's move along to question number 4. They ask you, how does the number of gas molecules affect the pressure? All right, so now, again, let's look at our pressure somewhere around 14. It does hover up and down a little bit. So we want to know, what about if we add more gas molecules? Will that affect the pressure? So let's go ahead and do that. So we're going to add more gas molecules here. So we're going to go use our gas pump and add more gas molecules. And as we keep the temperature constant, you see that now we got a lot more gas molecules. So what happened to the pressure? It increased. Now it is at 48. What happens if we add some more gas molecules? Notice that the pressure keeps increasing. Now we're at 63. So more gas molecules increase the pressure. Why is that? Again, there's going to be more collisions against the walls of its container. More collisions creates more pressure. So now what about the opposite? What if we remove gas molecules? I'm going to go ahead and do that. So we're going to let some of our gas escape out of our container. And now you can see our pressure is decreasing. As we let more gas molecules out, that's going to go ahead and decrease the pressure. So more gas molecules means more pressure because there are more collisions. On the other hand, less gas molecules, that's less collisions, so therefore less pressure. So that is the relationship. Up next, our final question is, how does the volume affect the pressure? All right, so now we have a fixed volume right now. The pressure is somewhere around 17 atm. So what happens if we were to go ahead and expand the container? So we're going to expand it all the way out here. All right, what happened? Our pressure went from 17, now it's down to around 11. Why did the pressure drop? Well, now there's more space for the molecules, so it's going to take a little bit longer for one of these gas molecules to go ahead and hit the wall of the container. So therefore, there are less collisions around the wall of the container, and therefore less collisions means less pressure. If we do the opposite by reducing the volume, so we're going to make it very small. Now these molecules are closer, they're going to go ahead and collide against the walls of its container more often, so therefore the pressure increases. Now you see the pressure is somewhere around 34 to 35 atm. All right, so that goes ahead and takes care of this simulation on what happens to pressure and volume, temperature, and the volume of a gas. So I want to go ahead and go step by step for each one of these, put it into writing. It says, how does a gas create pressure? The answer for that question was the force created by the collision of a gas molecule against the surface of its container creates pressure. The second question was, how does the temperature affect gases? An increase in temperature will make a gas molecule move at a faster speed, and vice versa. A decrease in temperature will make a gas molecule move at a slower speed. The third question was, how does the temperature affect pressure? An increase in temperature will lead to gas molecules moving at a faster speed, which means that the gas molecules will collide with greater force and more frequency against the walls of its container. So that's what's going to go ahead and create more pressure. The opposite will occur when the gas is cooled. Our fourth question was, how does the number of gas molecules affect the pressure? The answer, an increase in the number of gas molecules will lead to more collisions between the gas molecules and the walls of its container. This will lead to an increase in pressure and vice versa. If you decrease the number of gas molecules, there's going to be less collisions, and therefore less collisions means less pressure. And the last question, how does the volume affect pressure? So the answer for that was a larger volume will lead to a decrease in the number of collisions between the gas molecules and the walls of its container. Therefore, less collisions will lead to a decrease in pressure and vice versa. All right, so that takes care of our gas properties. That is how pressure, volume, and temperature affect a gas inside of a container. Up next for us, we're going to go ahead and move to how you measure pressure. Now, pressure is defined as the force per unit area. Again, how much force a gas molecule puts on the surface of a container when it collides against that surface. So gas pressure can be measured using a barometer. A barometer is a tool that you see in that picture on the screen, and it is essentially a tube shaped like the letter U, and on one side it's a vacuum, and on the other side you have mercury, and the mercury will either go up and down depending on the pressure on the outside of that test tube. So that is called a barometer. Now, units for measuring pressure, there's quite a few units for measuring pressure. So they are, the most common one for science is atmospheres, symbol for it is ATM. There's also torrs, mmHg, which stands for millimeters of mercury, kPa, which is kilopascals, or psi, which is pounds per square inch. Now, all of these units are equivalent to each other, so they are the same. So 1 ATM is the same thing as 760 torr, which is the same thing as 760 millimeters of mercury, which is the same as 101.3 kPa, which is also the same as 14.7 psi. So they're all equivalent to each other. Now, these units, you'll come across them in everyday life. For example, in the picture on the left, you see that it's measured in torr, so that gauge right there. And if you see the picture on the left, at the bottom of it is zoomed in, so you can go ahead and see the symbol for torr right here, which is right there, just to zoom in on the picture. The middle picture at the top, that is a tire, and you can go ahead and see that it's measured in 2 units, kp and psi. And here's their close-up for psi. This particular tire can handle 60 psi, which is about the same as 420 kPa, kilopascals. And the picture on the right, this is a blood pressure sensor, so it measures the pressure for blood inside of a person. And very small right there in the picture, here's the zoom in of that. It is millimeters of mercury, mmHg. So all of these are units used to measure pressure. And what we're going to go ahead and do next, we're going to go ahead and take a look at how can we go from one unit to another unit in measuring pressure. For our first example, they asked us to go ahead and convert from one unit to another in pressure. So we're given convert 3 ATM, atmospheres of pressure, to millimeters of mercury. Again, 1 ATM is the same thing as 760 millimeters of mercury. So we're going to go ahead and exchange from one unit to another. So I'm going to go ahead and write down my given, which is for our example A right here, part A, 3 ATMs of pressure, and now I want to go ahead and convert it to millimeters of mercury. So I need the denominator to match. It's going to be atmospheres, so that way they can cancel each other out. On the numerator, that's going to be what I'm solving for. So that goes on the top. All right, their values for every 1 ATM, there's 760 millimeters of mercury. So set it up like so. Next, I go ahead and put it into my calculator. It's going to be 3 times 760 divided by 1. So it's going to give me an answer of 2,280 millimeters of mercury. In part B, they asked us to go from millimeters of mercury to kPa, kilopascals. So we're going to again write down our given for part B. 1520 millimeters of mercury. And so we want to cancel those out because we want to replace them with kilopascals. So it's going to go ahead and be millimeters of mercury in the denominator. Again, the denominator always matches the given. And then the numerator is our new unit we're solving for, which is kPa, kilopascals. The values for it, a kilopascal is 101.3 for mmHg, millimeter of mercury, which is 760. So in my calculator, I'm going to go ahead and put 1520 multiplied times 101.3 divided by 760. That gives me an answer of 202.6 kPa. That takes care of part A and B. Up next in problem number C and D, we're going to go ahead and answer the similar question. This time they give us PSI, pounds per square inch, and convert them to millimeters of mercury. So let's go ahead and do those. So we have our given of 73.5 PSI. And again, convert them from PSI to millimeters of mercury. So our setup, the given and the denominator always match. So we're going to put PSI in the denominator so that way they can cancel out. And what we're solving for will go in the numerator. In this case, millimeters of mercury, mmHg. So that's going to be values for them, 760 millimeters of mercury. PSI is 14.7. So there you have it. And my calculator, what I'm going to do is I'm going to put 73.5, and I'm going to go ahead and multiply it times 760, and I'm going to divide it by 14.7, so it gives me an answer of 3,800 millimeters of mercury. PSI gets canceled out. Up next is the letter D. Now we're given kPa, kilopascals, and asked to switch to ATMs. So I'm going to go ahead and set it up like so. Here's our given, 506.5 kPa. kPa and the denominator, the given and the denominator always match. Alright, what we're solving for, our new molecule goes on the top, ATM. Alright, so values for kPa, it is 101.3. And ATM is just 1.0. So it's just going to be 506.5 times 1 divided by 101.3. That goes ahead and gives me a value of 5 ATMs. Okay, and lastly we're going to go ahead and do two more problems, E and F. And for this one, letter E, it says convert 20 ATMs to PSI. Alright, no problem. So, letter E, our given is 20 ATM. And we're going to go ahead and switch it to PSI. The given and the denominator always match. Their new molecule will go in the numerator, PSI. For every 1 ATM, there's 14.7 PSI. So there we have it. So it's going to be 14.7 times 20 divided by 1. Gives me 294 PSI. Lastly, letter F. And in this one, our given is 810.4 kPa. And we're asked to switch it to PSI. So our given's in kPa, our denominator is going to be in kPa. We're solving for PSI, so our new pressure is going to be in PSI. We put that in the numerator. Their values, PSI is 14.7, so I put that in the numerator. kPa, 101.3. Put that in the denominator. Alright, next I'm going to put 810.4 times 14.7 divided by 101.3 gives us an answer of 117.6 PSI, and that is our answer for letter F. Alright, so we went over 6 problems on how to change from one unit of pressure to another, and that brings us to the conclusion of this week's lesson, and thank you so much for watching.